Greetings. So, welcome to this course on fundamentals of automotive systems. So, we will start this course with a broad overview of what we learn, and then we will go to the first module. Okay. So, what is the objective of this particular course? As the title mentions, the broad objective of this particular course is to gain a fundamental understanding of various systems that constitute a typical automobile. Okay. So, as part of this course, we are going to learn about the automotive powertrain. We will learn about existing powertrains, which are typically called as conventional powertrains. So, these include the prime mover, which in conventional vehicles is an internal combustion engine, typically abbreviated as an IC engine. Okay. Of course, if you take electric and hybrid vehicles, you will also have an electric motor which may supplement the IC engine, or in a pure electric vehicle, an electric motor will do the prime mover's job. So, this includes a prime mover. It will also include the drive train or drive line, which essentially consists of the clutch and the gearbox. So, as part of this course, we will look at both conventional engines, IC engines. So, this is something we are going to spend quite a bit of time in this course. So, we will look at conventional powertrains driven by IC engines. We will also look at alternate powertrains, okay? So, which include electric and hybrid powertrains. So, through that discussion, we would identify the pros and cons of each class of powertrains, and we would also do a preliminary analysis of both. Okay. So, that is one module, one important module in this particular course. So, the next module will be on brakes. Okay. So, we would look at both hydraulic brakes, which are typically used in light motor vehicles like passenger cars, like even light commercial vehicles and so on. We would also look at air brakes, okay, hydraulic brakes, and air brakes that are used in heavy road vehicles like trucks and buses and so on. Okay. So, we will look at the construction, operation and features, analysis and so on. We would also look at concepts behind how the brake system performance affects vehicle stability, and that will motivate us to learn about anti-lock brake systems, okay, abbreviated as ABS. Okay. So, we will also look at the philosophy behind ABS, how does it work, how is it realized in practice, and what are the critical aspects that an automotive engineer should be aware of as far as its operation is concerned. That is also something which we will learn. The next module will be on steering, okay, vehicle steering. So, which will essentially look at various steering mechanisms. So, as we know, a steering system is very important to ensure that we can orient our vehicle in the direction that we want, right. So, if you want to turn, if you want to control the heading of the vehicle, this becomes very important. So, we are going to look at the automotive steering mechanism. We are also going to look at as part of the steering and the suspension module an important notion which is called as wheel alignment. Okay, the steering and the suspension and the wheel, like put together should be oriented and assembled in a certain way, and there is a set of parameters which essentially quantify this alignment between these various systems, which is typically studied under what is called as wheel alignment. Okay, we learn what is wheel alignment, what are the important parameters that characterize wheel alignment, and what is their impact on the automobile as such, right. So, we will also look at vehicle suspension. Once again, different classes of vehicle suspension, okay, and what to say, how they operate and what are the critical attributes and so on. Okay. So, when we look at suspension, we would also look at wheel assemblies and tires. Okay. So, because these are also extremely important, how the pneumatic tire is interfaced between the vehicle structure, okay, and the road becomes extremely important, because as far as a road vehicle is concerned, we are all the forces that are transmitted on the vehicle are through the contact between the tire and the road surface. So, a basic understanding of this interface and the tire and the wheel assembly becomes very important. So, we will also look at that aspect. Okay. So, our overall objective of this course is to gain an understanding primarily of these systems, and in every module there are going to be three broad classes in which I would segregate the information into. So, in each module we will first look at the components that make up the system, okay, and the realization of the system. So, what do I mean by that? Like for example, if we start with the internal combustion engine, we are going to look at what components constitute the internal combustion engine, how are they realized in practice. So, that is something which we will start off with. Then we will also look at how do they operate. So, how does each system function? How do various components function and interact with one another to achieve the desired task? Okay, so that is something we will look at. Then we would also do analysis, preliminary analysis of each system, like based on fundamental engineering concepts. So, this would be the broad way in which we will organize the material, right. And the scope of this particular course would be primarily on what are called as single unit road vehicles. So, essentially we will be looking at road vehicles, we will not be focusing on off-road vehicles in this particular course. So, on-road vehicles, and what is meant by single unit is that like it is like a typical passenger car or a truck or a bus, right. So, there is no articulation, like in a tractor trailer combination. So, we are going to look at single unit vehicles, and of course, by and large we are going to look at single unit four wheeled road vehicles. Okay. So, just to narrow down the scope further on. So, that is going to be the scope of our course. Okay. So, the broad flow of this course is going to be in this manner. So, we will start with the powertrain, we will learn, we will spend quite a bit of time on understanding the automotive powertrain. Then we will go to what is called as the chassis. Okay. Typically, you put everything together, like people call it as the automotive chassis, right. So, essentially we are going to focus on these aspects, okay, as part of this particular course. So, to begin with, let me start with internal combustion engines. So, we are going to look at the powertrain. First, let us look at the prime mover. So, we will learn about internal combustion engines, their types, their components, their operation and analysis and certain important features. Okay. So, an internal combustion engine in general is a heat engine. So, what is a heat engine? A heat engine is a device that converts, right, thermal energy into, let us say by and large like kinetic energy, so that like we can get what is called as mechanical work, right. So, that is how people will typically define a heat engine. So, within the scope of our discussion we are looking at a device that converts thermal energy obtained from various sources into kinetic energy. It is an energy conversion device, right. So, as far as internal combustion engines or automobiles are concerned, what typically happens is that the chemical energy stored in fuels is first converted to thermal energy by the process of combustion, right, and then converted to kinetic energy, right, by using appropriate mechanisms, and which is used to propel the vehicle, right, through the wheel assemblies. So, that is what happens in a typical automotive engine, right. Now, if we look at broad classifications of heat engines depending on the attribute that we utilize, heat engines can be broadly classified based on how combustion and this energy, these two energy conversion processes happen, as what are called as external combustion engines and internal combustion engines. Okay. So, we are already looking at internal combustion engines, but let us look at the difference between the two. So, what do you think is the difference between the two based on the way in which I have written down this energy conversion process?
Combustion happens outside the system and then you give the energy into the system. If a chemical reaction happens outside the system where thermal energy is converted to kinetic energy, and internal combustion system, chemical energy, like the fuels are put into the system and then it's converted to thermal energy, then kinetic.
Yes. So, that is right. So, if you call this as energy conversion process 1, this as energy conversion process 2, in an external combustion engine, these two energy conversion processes happen in different components, right, or different places, right. So, let us say a good example of an external combustion engine, let us say we take our steam engine, right. So, I am sure all of us would be aware of steam engines. So, in a steam engine, what do we do? Let us say we convert water to steam in a boiler by burning some fuel, right, and then the steam is transported from the boiler, let us say, to a steam turbine, and there the thermal energy of the steam is converted to kinetic energy of the turbine components, the turbine rotor, right. So, you can see that these two energy conversion processes happen in different locations, right. So, that is an external combustion engine. On the other hand, in an internal combustion engine, the two energy conversion processes happen in the same chamber, right. So, our example is a typical petrol and diesel engines, right. So, what we use in typical automotive applications like come under what are called internal combustion engines. Okay. So, both the energy conversion process happen in the same chamber, which is typically called as the combustion chamber. Okay. What people call as the cylinder or the combustion chamber is the place where this energy conversion process, these two energy conversion processes take place. Okay. So, I hope the difference is clear, right. Our scope is going to be on internal combustion engines, and internal combustion engines which are abbreviated as IC engines, IC standing for internal combustion, okay. Some people will write it as ICE, okay. So, they can be classified based on the type of mechanical motion that is used in the energy conversion process too. That is how thermal energy is converted to kinetic energy, okay. So, if an IC engine uses reciprocating motion to convert the thermal energy into kinetic energy, then it is what is called as a reciprocating engine or a reciprocatory engine, okay. So, if a rotational motion is used to do this energy conversion, that engine is what is called as a rotary internal combustion engine, okay. So, that is the difference, okay, depending on how the second energy conversion process happens. So, here reciprocating motion is used to do the energy conversion process from thermal energy to kinetic energy. In a rotary engine, a rotary motion is used to convert the thermal energy to kinetic energy, okay. So, reciprocating engines are our typical, once again, petrol and diesel engines, you know, like most petrol diesel engines use a piston, right, in the combustion chamber to essentially convert the thermal energy into kinetic energy, you know, like basically you have translational motion which is essentially repeating, right, that is a reciprocating motion, right. So, a common example of a rotary engine is what is called as a Wankel engine, okay. So, where rotary motion is used to achieve this energy conversion process, okay. Our focus will be on reciprocating engines. So, we are going to look at internal combustion engines, we are going to look at reciprocating engines, okay. So, I am going to classify engines based on other attributes now, you know, shortly, you know, like then we will see what will be the scope of our discussion, right. Then you know, like based on the mechanism of combustion, or I would say ignition, okay. We will look at all these terms later on, okay. So, we can have what are called as spark ignition engines and compression ignition engines. Okay. So, spark ignition is typically abbreviated as SI, compression ignition is typically abbreviated as CI. So, I would expect you to know what an SI engine and what a CI engine refer to, right. So, SI means spark ignition, CI means compression ignition, okay. So, what does this mean, you know, like, so the terms themselves are self explanatory. So, what do you think is a spark ignition engine? So, yes, so as the name indicates, a spark, a high voltage spark is used to ignite or to initiate the combustion process, okay. So, in a spark ignition engine. So, in a SI engine you use a high voltage spark to ignite the combustion process. So, in general if you are looking at combustion per se, so that is the process by which the what to say fuel and air are mixed together and ignited in a what to say an engine to convert the chemical energy in the fuel to thermal energy. That is the first energy conversion process that I talked about, right. So, you need fuel, right, which are typically hydrocarbons, okay. We need air, mainly oxygen in the air, right, because it is an oxidation reaction chemically, and we need a mechanism for initiating combustion. So, we need these three what to say requirements or items, right, to have combustion. Of course, we need fuel and air in the correct proportion, okay. So, they should be in the correct ratio or correct proportion for effective combustion, okay. So, that is very important. So, if you look at the hydrocarbon in the fuel, like hydrogen should be completely oxidized to water vapor H2O, and carbon should be completely oxidized into CO2, okay, in an ideal combustion process. Now, even if I introduce fuel and air in the combustion chamber in the correct ratio, I need a mechanism for initiating combustion, right. That is where the above classification comes into play, right. In a spark ignition engine or an SI engine, I use a high voltage spark to ignite the mixture, the so called fuel air mixture, okay. So, we will use this term fuel air mixture, okay, to refer to a suitable mixture of fuel and air. Some people will also call this as charge, okay. They will use the term charge in the context of IC engines, means like they are referring to fuel air mixture, okay. The process of charging, which we will look at later, is to essentially the process by which we bring in fuel and air into the engine chamber, combustion chamber, and mix them properly, right, to get them ready for combustion. So, we will look at all those aspects as we go along. So, even if I charge the combustion chamber, right, I need a spark to ignite the mixture in a spark ignition engine, okay. On the other hand, in a compression ignition engine, what happens is that we push the engine operating conditions to such a level that the fuel ignites on its own, okay. Every fuel will have what is called as a self ignition temperature, and when you take the fuel to that temperature, it ignites on its own, okay. So, here fuel self ignites. So, you do not need a spark or any other external mechanism to initiate the combustion process. So, example, diesel engines are compression ignition engines, petrol engines are spark ignition engines, okay. So, for this reason like people will call as petrol as spark ignition engines, what to say, diesel as compression ignition or CI engines, okay. So, they are used interchangeably for this particular reason, okay. So, this is one classification, right. So, another criteria for classifying IC engines is based on the number of strokes in one operating cycle, okay. So, of course, in our course we will consider both spark ignition and compression ignition engines, okay. We are going to look at both, right. So, we will look at what is an operating cycle and what do we mean by stroke and so on, right, as we go along. So, based on this criteria, we have what are called as 4-stroke engines and 2-stroke engines. And as we can readily interpret from the term itself, a 4-stroke engine is an engine where we need 4 strokes of the piston to complete one operating cycle of the engine, okay. A 2-stroke engine is one where one operating cycle of the engine is completed in 2 strokes of the piston, okay. So, that is the difference. So, we are going to once again look at both, okay, and then like learn what are the pros and cons and so on, right. So, today 4-stroke engines are universally used in road vehicle applications. 2-stroke engines are are on the way out due to emission issues. We will figure out why, right, as we go along.